Assalamualaikum and hi everyone. Now we're going to discuss on piezoelectric transducer. Piezoelectric transducer means that the concept behind the transducer is based on the changing effect of piezoelectric. First, let's understand what is piezoelectric effect. The piezoelectric effect was discovered in 1880 by Pierre Curie in quartz crystal. The word present is actually meant to press, meaning the appearance of electrical potential in the crystal was found when it is subjected to mechanical pressure. An example of crystal that having this piezoelectric effect is like quartz, barium titanate, and tourmaline. The piezoelectric effect can be displayed by the displacement of ions in crystals. This effect occurs when the crystal is compressed. Therefore, the ion in the cell will have a displacement, and this will cause the electric polarization occur in the unit cell. Due to regularity of crystalline structure in the crystal, the electric polarization effect accumulates, causing the appearance of an electrical potential difference between certain phases in the crystal. This can be seen in quartz crystal, where the ion of the quartz crystal is silicon dioxide, SiO2. So we can see here, when mechanical force is pressing the crystal, the ion, oxygen, and also the silicon will displace due to the effect of regularity of crystalline phase. The voltage can be measured in the crystal. In piezoelectric transducer, there will be two effects in piezoelectric crystal. Such effects are longitudinal effect, which is when the force is applied onto the crystal, we will be able to measure voltage from the crystal. The second effect is what we call as transverse effect. This effect occurs when we apply the voltage onto the crystal. It will cause the crystal to expand. These two effects are the basic concept in the design of piezoelectric sensor and also piezoelectric motor. These are the example of sensor that using the concept of piezoelectric. We can see here there is a force sensor, pressure sensor, and accelerometer. All these sensor is using piezoelectric or piezoelectric material as the working principle behind the sensor. You can see here the gray area here is the test structure. The red is the piezoelectric crystal, and this blue thingy is the housing. For example, in force sensor, when the force is applied onto the crystal, it will cause the ion to be displaced in the crystal, and the effect will be accumulated before it being amplified by the amplifier here in the microcircuit. So the output from the force sensor is a voltage. Same in the pressure sensor here. A pressure is applied onto the surface of the sensor and change into the force, where force can be calculated using F equal to PA. So when the force is applied onto the crystal, it will cause the ion to displace, and then the effect will be accumulated and amplified by the microcircuit here. The last one here is the accelerometer. accelerometer is used to measure acceleration or vibration. So in order to convert acceleration into force, we need to have the seismic mass here, which is the green block here. By having mass multiplied with the acceleration, we get force applied onto the crystal, then the ion displays and accumulates and then amplified by the microcircuit, then will give us voltage. So these three sensors use the concept of piezoelectric as the working principle in their sensor. The relationship between displacement and force is given by X equal to 1 over K multiplied by force, where K is the stiffness of crystal and typically the value is very large. The piezoelectric sensor behaves as a second order differential equation as shown in this equation. Omega n is the natural frequency. The natural frequency for this kind of sensor is large, typically between 10 to 100 kilohertz. The damping ratio is small, which is around 0.01. The deformation or the displacement of crystal results in charge. So the net charge is proportional to Kx, which is equal to K over Kf or dF, where d is K over K, which is in coulombs per Newton unit, which is a charge sensitivity to force given by this value. By looking at this equation, we can say that the electrical current is proportional to the force applied onto the crystal. Piezoelectric sensor is a passive transducer where it does not require power supply and the output is very small, which is only within 1 to 30 millivolts. A common application for piezoelectric sensor is in combustion monitoring, where it measures the pressure that develops during the combustion process by putting the piezoelectric sensor on top of the head. The advantage of piezoelectric sensor is that it will have a high stiffness value, meaning it will produce a high output with very little strain. The sensor is also ideal for rugged use, and the linearity is excellent over a wide amplitude and also ideal for continuous online condition monitoring system. And the cons of the piezoelectric sensor is that it only can be used for dynamic pressure sensing, because if the signal is static, then the signal will decay away. And the second cons is the operation over long cables may affect frequency response and introduce noise and distort. Therefore, the cables need to be protected. As I mentioned before, there are two effects in piezoelectric, where the first effect is the direct effect. When we apply force onto the crystal, such that in here we apply tension, then we get bigger voltage. If we compress the crystal, we get smaller voltage. If there is no force applied onto the crystal, they will give you 0 voltage. The second effect is the converse piezoelectric effect. This effect is occur when we apply voltage onto the crystal. For here, when we apply 0 voltage, there is no displacement occur in the crystal. But when we apply positive voltage, the crystal will expanding. And next, when we apply negative voltage, the crystal will be shrinking. So using the direct effect and converse effect, we can design or use the piezoelectric crystal as a piezoactuator or piezo sensor. So piezoactuator is actually convert electrical energy into mechanical energy. This is used the converse effect. As for the piezo sensor, it will convert mechanical energy into electrical energy such that we apply force onto the crystal, then we measure the voltage. The important key properties in piezoelectric is the ability of the crystal to produce voltage when we apply a stress, and also the ability to produce a strain output when respond to the applied voltage. So this one is the direct effect, and this one is converse effect. This is the example of piezoelectric application in electromechanical device. The example is in microphone. Piezoelectric microphone convert strain from the sound frequency, then convert it into electrical field. Similarly, in speaker, the piezoelectric material is used as an actuator, where the piezoelectric material convert the mechanical strain into sound. Similarly, in speaker, a voltage input is applied onto the piezoelectric material and converted into mechanical strain. Second application of piezoelectric is accelerometer. So, accelerometer is a sensor that used to measure vibration. The accelerometer uses the piezoelectric material in the housing that act as a seismic mass that will convert the acceleration to force by the equation F equal to ma. Next is the piezoelectric motor, where these piezoelectric motors are driven by ultrasonic vibration created from the piezoelectric transducer. Last one is piezoelectric drill, where we can see here we have a stack of piezo applied by the input voltage, and it will expand the material, and the effect is accumulated by put a stack of piezo, then it will convert into large acceleration by the free flying mass. The free mass impact on drill bits create a stress pulse at the drill top, causing fracture in the rocks.